Hey there, everybody. So I'm going to tell you now a little bit more about function families. We learned in class that although most times the universe, at least a lot of times the universe acts with linear functions, that's not the only kind of function. In Math 1, I'll tell you about three kinds of function families, okay? Linear, and then another function family called inverse, and then another function family called exponential. They all have different tables, they all have different graphs, so we'll just get a little taste of them, okay? Let me just tell you what they look like right away. If you have, this is the one you already know here. Linear functions, if you ever see them, they just look like a line, right? Easy peasy. If you have inverse functions, I'm just going to draw the first quadrant here, going like that.
How you come to the guidance office? How you come to the guidance office?
So this, I kind of think of them as coming in for a landing, because you see how this line just coasts towards the x-axis. It never actually touches it, but it coasts to the x-axis, okay? So it's coming in for a landing. That means inverse. That's a way to keep it straight. Because the other one, exponential, has some similarities. It's also curved, but you can tell it's going up, right? In fact, it's rising extraordinarily fast, right? So it's going extra fast. So that's why I think of exponential as going up extraordinarily fast, or just using some x things so I can keep them straight. Inverse comes in for a landing. Exponential increases quickly at an extraordinary rate. So we're going to do the first two problems together in the homework. So you should pause this video and then just grab your homework so you can just do it with me, and then shazam, you got two problems done, okay? So here's the first problem. It says this. A company has $100 to split among its employees. The independent variable is how many employees are splitting that 100. The dependent variable is how much money each employee gets. Okay, that might not make sense so far, but let's just keep going. Make a table, it says, of this situation and label the columns. Okay, so on your piece of paper, you should follow along. So here's number 1, and I am going to make a table, and I am going to label my columns, it says. So the independent variable, kids, that's the one that comes first. That's the x. In a function box, it's the input. So my independent variable is how many employees there are, number of employees. I'm just going to abbreviate here, okay? Number of employees. And my dependent variable, so that's the y, okay? That's the output variable. That is how much money each gets. So amount of money each gets. Again, I'm abbreviating. So check it out. Let's just say there's one employee. Do you agree they get all $100? So that's an easy one. What if there are 2 employees? Well, then how much does each one of them get? 50, right? So I'll put a 50 there. Now, I'm going to avoid some of the trickier numbers just because you guys can do it on your own, but I don't want to use up time. Let's say there are 5 employees. Then how much does each one get? So if you have 100 and you split it in 5 ways, I think that's $20 each. And then let's just do one more, 10 employees. So if you have 10 employees and you're splitting that $100 10 ways, do you agree it would be 10 then? Okay, you guys, I'm done with part A. I made a table. So now I'm going to make in part B, it says make a graph and label the axes. Okay. So we'll make a graph. I'm just going from the table form now to the graph form. You see how that those 4 forms, they come in handy, right? That way you know what I'm talking about when I say going from a table to a graph. So I'm not going to go by ones here, okay? Because look, there's a lot on this y-axis. So I'm just going to go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, okay? I would normally, I'll put them in, whatever. I'm trying not to use up too much of your time here. And then I'm going to go by ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you guys pause the video because I know I'm writing fast. That way you won't feel stressed out. So this is the amount of money each gets. Amount of money each gets. And this is the number of employees. Okay, one question to you. Actually, I can't really see what I've got. Hold on, I just want to make sure that's all visible to you guys. Okay, so one question that I want to ask you right now is, do you think this is going to be linear or inverse or exponential? It's kind of nice to just kind of guess. Well, let's see if you're right. So over 1 and up 100. Over 1 and up 100. Over 2 and up 50. Over 5 and up 20. Over 10 and up 10. Kids, does that look linear to you? No way, right? No way. This guy comes in for a landing, like that, right? So in part C, it says, is it linear, inverse, or exponential? Guess what? This is an inverse function. Shazam, we are done with number 1. Okay? So I'm going to do number 2 with you now. I'm going to erase my board here, and then we will get to it. All right. Number 2, let's see what number 2 has to say to us. A certain kind of bacteria reproduces, that means it splits in half, once every minute, and at time 0, there's just 1 bacterium. Okay. Independent variable is elapsed time in minutes. The dependent variable is how many bacteria there are. And then kids, it's the same 3 questions every time. You make a table, you make a graph, you tell me what kind of function family it is. So let's make a table of this, and I'll show you. I figured you guys would be a little bit confused by that situation. So I'll draw it out for you so you can see it, okay? So here's what's happening. You got 1 bacterium, right? And then after 1 minute, it reproduces by splitting in half. So can you tell now if this is like my time going on here? We've got 1 bacteria. Can you tell we have 2 now? Now here's the thing. After 3 minutes, don't each of these splits? So guess how many bacteria I have now? There's 4, right? And then after the 4th minute, then how many bacteria do I have? Do you see what's going on, you guys? So are my number of bacteria going up? Yeah. Are they going up by kind of a lot each time? Yeah. Because look, I'm not going to draw it, but the next time, can you tell there'd be 16 bacteria? Okay. That's what's going on. Let's make our table. So I've got, let's see, elapsed time. So I'm just going to write time here, okay? And that's in minutes. And then this is the number of bacteria. So at time 0, I started with 1 bacteria, right? I'm so sorry, you guys. I'm off on that. My bad. At time 0, I have 1 bacteria, right? Now, at 1 minute in, guess how many bacteria I have? There are 2 of them. 2 minutes in, how many bacteria do I have? 4. 3 minutes in, how many bacteria do I have? 8, right? And can you tell what's happening for each minute, you guys? Can you tell what happened with 4? It's just multiplying by 2 each time. We could go more. Let me just go one more so you can see how startling this is. It'd be 32, right, if I go 1 extra minute. So now I have to graph it for part B. So here's time in minutes. And then number of bacteria. It's always good to label your axes, kids. Okay? Now, I'm going to go by, I'll go by 5s here, okay, on the y-axis, because I got to get up to 32. So here's 5, 10, 15, 20, 25, 30, 35, and then I'll just go by 1s. 1, 2, 3, 4, 5. Again, slow the video down. I know I'm writing fast. That way you can catch up, okay? Okay, well, let me ask you, before I graph it, do you think it is linear, inverse, or exponential? Well, let's see if you're right. So over 0 and up 1. Bam. Over 1 and up 2. Bam. Wow, it's not going anywhere. Over 2 and up 4. Look at this. It's so tiny. It's barely rising at all. Over 3 and up 8. Oh, I jumped a bit. Over 4 and up 16. Holy cow, that was a big jump. And then over 5 and up 32. Holy moly. Can you guys tell? Is this going to be linear? No way, right? No way. Look at this thing. And look at, I mean, if we just went one more, it'd be at 64, like it'd be up here, right? And another one, what's double 64? 128. That's crazy. So this thing skyrockets up, whatever. Guess which function family this is? Well, it's not coming in for a landing. It's growing extraordinarily fast. This guy is exponential, a brand new function family. That's the answer to part C. That's how you do the rest of these problems. Email me with questions, okay? Good luck.